This is the most used tool in my shop. It is a very cheap, very old bench vise that my parents bought me when I was like 16. I hit it once so hard I saw sparks while trying to forge something and trying to break something that I put a gash right through this, which actually helps me align up these jaws, which is what we're talking about today. These jaws are made out of steel. This is a piece of aluminum TIG wire. When I put it in here nice and tight and then undo it, oh, I did that with one hand, it bends the metal. That was really bad. I didn't even do it that tight. So what I want is a pair of jaws that go in here that are made out of aluminum. The difficult part, I have the aluminum to do it. I'll show you, it's a piece of scrap aluminum. The difficult part is going to be doing these countersunk holes right here because I don't have a countersink. So I'm going to have to see if I can figure this out. There's 2 bolts holding each of these on. I'm going to start by taking those off and taking a look at them. Alright guys, dust that off for you guys here. Aluminum powder everywhere. This is a standard drill bit taper. This might be hard to tell, but this bit is slightly more pointed than this bit. This one's flatter. This one is more steep this way. This one's more angled this way. This right here, based on my eyeballing, and I'm pretty sure they're the same, is the same taper as this. But this is steeper over here. So same taper here. Now, I could just use this to drill out, and then, so the idea is going to be to use this bit first, and we'll make a pilot hole, and then use this bit and kiss through it and kind of use it as a chamfer tool, even though it's not really what it's designed for, and then that'll have the same fit for that, but this bit is slightly smaller in diameter than the head of this screw. So what I'm going to do, what I'm thinking of doing, and this is not perfect by any means, but I think it'll be good enough for this cheap-ass vise. Pilot hole through this, bore it out to the proper depth with this in order to make the angle right, and then kiss out the corners with this higher one here, just until this fits in deep enough like this. So there'll be a little bit less contact pressure on the screw, but aluminum's pretty soft. It may even bend a little bit if these get on there real tight. And like I said, I think it'll be okay for this type of application. So that's what I'm thinking for the holes. We've got that thought through. Now what we need to do is we need to go replicate and build 2 of these out of aluminum. This is a scrap of aluminum that I bought. It's very long. As you can tell, it goes all the way down the table. I bought this because it has a perfect 90 degree, and I bought it for welding, and it'll act as a good heat sink, so you can clamp something here and here, and then you can weld on the corner and make a perfect 90 degrees, and it acts as a heat sink because it's made out of aluminum. So I bought it for welding aluminum to pull heat out so you don't blow out your part. But this happens to be the exact same diameter as this, or thickness, almost exactly. If you're doing this at home, you can do it with something either this exact same or slightly bigger. If you go slightly smaller, you just got to make sure that your vise doesn't touch somewhere else other than where the jaws are. So that'd be the only thing to keep in mind for that. I think I've found a clever way to make this in the least number of steps, and let me get showing you guys how I'm going to do that. Alright, those holes are drilled through both pieces, and as you can see here, I have them bolted together, and that way I know both holes are exact. And then I scribe the outline of the jaw onto there, and now I'm going to cut it out, and I'm going to come just outside this line, try not to go into it, and then come in and grind it down. And I'm going to do both these pieces together. That way all my work is done at once. And then I'll take them apart and do the drill bit parts in to get the sunken head bolts in there, the flathead bolts. And then this is more efficient doing it this way by cutting out. This way you only have to cut it out once instead of cutting it out twice, and you know they'll both be the exact same piece. This is especially helpful if you need something to be the exact same shape. It's not as important here, but it's just a little bit more efficient to do it this way. So now I'm going to cut these out roughly, and then I'm going to go in and kind of bring them down a little bit. Alright, here we are. So I have the aluminum parts sandwiched in between the two steel parts I took off, and then I have the bolts lined up. And you can see they came out fairly, if we want to focus, there we go, fairly good. This side is really flush. This seems pretty flush over here, maybe a little bit high right there. For whatever reason, this corner is sticking out, so I'm going to grind that down. And now essentially what I'm going to do is I'm just going to hit it with the grinder. And my grinder is set up as just about as ghetto as my bandsaw setup. So I'll show you that. Alright, after a little bit of finagling on with the file and such, I got these fitting, and now I'm going to go in here and I'm going to try to do these countersinks. Let's see how that goes. Just eyeballing this. Alright, that looks about right there. Let's switch to the other bit, knock that down until we're fitting in there. It's looking close. Alright, instead of using that giant bit, I'm just going to try to recess it with this one, which is right about the same diameter as that. Should have thought of this at the beginning. This hole is looking crazy now, but yeah, that's recessed right there. Look at that. Or there we go. Look at that. Yeah, that'll work. Alright, now I just need to do that 3 more times, and we'll get these on there and see how they work. Seeing a little bit of a high point on this one. Let me grind that off real quick. Alright guys, that looks like it's going to work. Not the most precise things. There we go. Look at that. There you go. They're not very even, are they? But there we go. Alright guys, there they are. They look pretty good. I mean, they're a little sloppy. Let's be honest. They're not high precision anything by any means. But like I said, this is a cheap Vise, so why would I need crazy ones? I'm pretty happy with them. Now I can grab stuff without marring it, and just to test it, there it is in the vise. Let's get it nice and tight, like that. Grab it, and that's pretty fucking tight. Probably too tight for a wire that tight anyway. Let's see if we left any marks on it, shall we? A little bit. I guess that's what happens. I don't know if you can see that. Yeah, you see that flat? Well, yeah, you see that flat? So it did mar it a little bit. Let's see if it marred the jaws. It did not. You might not be able to tell, but it did not mar the jaws. I think that's just the simple fact that this is really thin gauge stuff. What we could do, just to be clear, it was not as bad as the steel jaws, but let's stick this in here and grab it tight and see what this does. Alright, as you can see, that is in there real tight. Let's pull it out. Yep, I see nothing. Good, so if you're holding anything other than TIG wire, this will work. You probably could hold TIG wire with it, just not that hard. Success! Alright guys, thanks for watching. I hope you enjoyed that. I hope you got something useful out of it. I assume if you're clicking on this video, it's probably because you're interested in building those, or you're watching it because you're a fan of my channel. But the entire reason I built that is so I can hold aluminum, and the reason I need to hold aluminum is because I'm building a working Iron Man suit out of aluminum. Let me say that again. I'm going to build a working Iron Man suit, and it's going to be made out of aluminum. That's the entire point of this channel, this YouTube channel. That right there is my TIG welder that allows me to TIG weld aluminum. This over here, that thing right there, is a custom tool I designed to build artificial muscles that happen to be the highest strength to weight ratio actuators. And actuators is a fancy robotics term for something that moves something, so like motors or actuators, stuff like that. I have the highest strength to weight ratio actuator ever made, and I use that machine right there. It's a custom machine that was welded together with a stick welder, not a TIG welder. To build those, there's a lathe over here, back here behind this cart. Wow, there's my lathe. I'm going to build some of the parts for the suit on that as well, but most of it is going to be water jet cut, and then I'm going to use that welder right there to put it together. I also have an exciting video coming out soon that I'm going to start. I'm still in the design process, but I'm going to be building a really awesome cart for that as well. So if you're interested in that, smash the subscribe button. And if you're curious about what I'm doing, stick around because I'm going to show you the other thing I did today, and that was build the pelvis part of my exoskeleton. Not all of it, but I did some of it today. I'm going to show you that right now. Alright, as promised, here is my exoskeleton. So this is a 3D scan of me, right here. I paid to have this done by a third party. A company here in Denver, Colorado does it. And what I have finished today is there's a deep layer, which is the parts I just turned off, and then there's a superficial layer like this. There's two layers to the exoskeleton. And then there'll be a joint that goes through here, through these two pieces right here. My cursor's nice and big now so you can see it and see what I'm pointing at. There'll be a joint that goes through here, and that'll be up on your lumbar, and that'll allow you to go forward and back. There'll be two in that plane, and then there'll be another one in the center plane to allow you to go this way, and there'll be another one running right through the middle that has something called slider joints, which there's not an example of here, but that'll allow you to turn this way. There's 3 different types of joints in this suit. You can't actually, there's not any of the joints actually here developed yet. These two will be hinge joints right here, but they're not there yet because I'm building out the framing, and then I'm going to put the stuff on there after. But then there'll also be a joint. You see parts of the suit are cut to accommodate the joint movement. And this joint right here, and then there'll be a smaller one sliding off the front, will allow you to bring your legs up like you're doing the splits, though only about 10 degrees because exoskeletons, they're kind of bulky. And this one is no exception. And then hopefully future iterations of this, like the Mark II, will be even more higher range of motion than this. But this is the Mark I I'm building right now, so if you're familiar with Iron Man and what he does, that's how he named his suits. This is his naming system, and it is mine as well. But this is pretty cool. This geometry comes out and curves around like that, and it comes out in 1, 2, 3 pieces to get back to this, and this accommodates
you can see how this accommodates the leg moving out like this. And that's the point of this being flanged out like this. Like I said, it's a little bulky. When you bring your hands down, they won't be able to come down all the way. But that really is just kind of how it is. The main part that comes out is this butt piece right here, and you can see that that's actually not interfering with my legs straight up to the side. So, and then maybe my hands coming down too will still be comfortable. So it kind of sticks out a little bit more in the back is essentially what I'm saying. I think this has got really good curvature to it. I really like the way this came out. I think I'm really liking the feel of the pelvis right here. Still have the torso open, guys, who have been following this. Haven't really done much with it today. If you're new to the channel, this is the torso that I'm working on right now. Still need this joint in here, but because I've decided to bounce around a little bit, I'm not going to worry about this right now. I'm going to try to I'm going to come back to this and work on it when I actually start working on the shoulder girdle. So for now, I'm not fucking with this. I will later. But I think this is actually pretty good. I still don't know about maybe that extra strut in there. I still kind of want to add that. So there's a chance this one will be redone, but it will go much faster. I mean, this one did not take me all that long to do because I had a good idea of how I was doing it because it's so similar to the torso. And this is by far the best one I've made yet. It looks real good. This one looks really, really good. So I'm really happy for this one. I like the way it goes together. I like pretty much everything about it. There will be, you won't be able to see on this shitty camera, but I actually took this TIG wire out here, what was in the jaw earlier, and I chucked it into the lathe, and I brought it down on a chamfer, and I made it nice and smooth. And there's going to be some alignment pins that come into here. So remember, this thing is put on in 2 layers, so if I take the ventral side off here, you can see like that. Let me turn the deep stuff off. So the deep stuff would already be on, but that would just be the back part that comes on, boom, and then this part would come in here and get slided on this way. And this hole right here, these should actually be different sizes, but this inner one would be tapped, and this outer one would be bigger to accommodate the bolt going through it, and then it'll be recessed just like those bolts that I was using on the soft jaws today, just those exact type of bolts I'm using here, so it'll be completely flush. I'm going to have a tool, though, that actually does that, so I'm not going to have to fucking jury rig it with fucking just random drill bits in my garage. I'm going to have a tool that is precisely cut to match those, and then there's a thing that goes on it, and you can set the depth so you don't go too far and bore it out, so you don't have to eyeball it. And you can do them with hand drills, too. I don't have a drill press. I could get one if I needed to. If I really needed to, I could save up some money and buy one on Craigslist. But they look like they work pretty well just with hand drills. So anyway, that'll be chamfered out and recessed for those bolts, and then that will come through and bolt right there. And then in these holes, like I was talking about, there's going to be some alignment pins that are going to be just made out of this, and then I'll just plug weld the backside, and then they'll stick out and they'll go into these holes right here, and that'll just keep it from moving around in every plane except pulling it apart. So it'll keep any kind of jiggling like this from happening. So suit's coming along. I like moving around. I feel more efficient when I'm doing it this way. I also feel less stressed doing it this way, where I am bouncing around. I'm going to start the head tomorrow, and then I'll bounce back to this, and then I'll bounce back to the torso, and I'm going to move around a little bit. I'm not sure I'm going to go beyond the head. I might try to get some more stuff started or finished before I do that, but I'm thinking about doing that. I may end up doing the lumbar and the neck at the same time too. So in a way, I'd be figuring out the entire trunk all at once if I did that. But we'll see what happens. So again, this is the part that I did today, and then this is the part that was done yesterday, and those are the deep parts. And those, by the way, go together in a similar fashion, except there's 2 bolts right here, like this, and you can see that this is how that part looks. And there's some curved parts that kind of just lock together and keep things from moving around. And then we go the other way like that. You can see this would be how it is right here, and this part would slide in like that. And then the idea with this is this back part, all the backbone of this, will be held on a stand, and then the front parts will be brought in and bolted in. And then a similar thing down the arms and legs. They should be holding the suit out in the stance that I'm in right now. The anatomical stance, so I guess the anatomical stance is a little lower. The Da Vinci stance, kind of like this, will be holding the suit in this, and I'll put my hands into the gloves, and then the deep part will come in, and then the superficial part will then all bolt on top of that. And the idea is going to be to have 2 stands, and the stand that is holding up the deep frame will be, once I get the front part of it on, will be removed, and then another stand will slide forward and bring in the superficial frame, and then the outside pieces will be put on. That's the idea. It's going to be pretty complicated. I haven't actually started working on the stand at all yet. I figured let's figure out the suit first, and then we'll figure out how the stand works. You guys are great. Thanks for watching. And if you're seeing this video for the first time, smash the subscribe button, because you know you want to follow me on my journey to become Iron Man. You know you want to see this. This shit's awesome. This shit's awesome. You guys are great. I love you.